Okay, Hi, Jordan.
Hi.
And we're going to talk about simplifying rational expressions. So just really quickly, let's look at that word rational. A lot of times that confuses people. All it means is something that can be expressed by a ratio, which is also a lot like a fraction. So we're going to be talking about simplifying expressions that are kind of in fraction forms. Does that make sense?
Yeah.
Okay, good. So let's first talk about this idea of simplifying by canceling. Canceling isn't a technical math term, but a lot of people use it. So let's go ahead and use it because a lot of times that makes sense for people to think in that way. So let's first look at an example A here. So 5 over 5, there's a rational expression because it's a fraction. Well, what's 5 divided by 5?
1.
1, right? So we know that that's 1. That's super simple, right?
Yeah.
Okay, so now let's look at something that's very similar to that, and it's 5x over 5. Well, you can see that we can divide the 5 by the 5 to get, what was that again?
1.
Good. And then that'll be just 1 times x, because this 5 divided by 5 is just 1. So what will be left over?
1x.
1x, right? And then we know that that's just the same as x. Okay, makes sense? Now, here's where this idea of canceling comes in. So some people will say, okay, well, there's 5x over 5. Well, the 5 divided by 5 is 1. So that kind of cancels, and you could cross those out. So then the only thing left is the x. Okay? So that's one way of thinking about it. Let's look at another example. Now here we have the quantity x plus 3 over the quantity x plus 3. So what's that going to equal?
1.
Right, it's just going to equal 1 because it's the same thing it's one thing over itself, or one thing divided by itself. So that's going to equal 1. Make sense?
Yeah.
Okay, but there is another way to think about that, and that's that those cancel to equal 1. And then there's also, with these kinds of expressions where you have some variables in it, there's a little bit of a gotcha that you can have. And that gotcha has to do with what x can equal. So a lot of times you'll see an expression that's a rational expression with a little bit of extra information here. In this case, it's x is not equal to negative 3. Now, if you want to be really technically correct, you need to write that, because if x were negative 3, what would the denominator be?
0.
0. It would be negative 3 plus 3, that would be 0. And when you have 0 in the denominator, that's undefined, right?
Yeah.
So it's so undefined that we can't even say that that cancels to make it equal to 1, unless we know that x does not equal negative 3. So that's a little bit of a gotcha you might run into sometimes. Let's look at one other example here with canceling. So here we have an expression on the top that has 2 parenthetical terms over another one that has 2 parenthetical terms. And you can see that one of the parenthetical terms is x plus 4 in both the top and the bottom. So what can you do with those ones right there?
We can cancel them.
Right. So we'll go ahead and cross those out. And then what's left?
We have x minus 5 over x plus 2.
Good. And that's great simplification. You can see that this is a lot simpler than this thing right here, right?
Yeah.
Okay, good. Now, sometimes you don't have it in this form here because you need to factor a trinomial or some other expression first. So let's go over here and look at factoring first and then canceling. So let's look at an example. We'll call this example D. So you might remember that factoring, you want to look for something that multiplies to be, in this case on the top, 6 and adds to be 5. Can you think of two numbers that multiply to be 6 and add to be 5?
6 and 1.
6 and 1 would work because 6 minus 1 is 5, but that would be a 6 and a negative 1, and those would multiply together to be a negative 6. Can you think of another set of numbers that would add together to 5?
2 and 3.
Good. That's excellent. So we're going to have on the numerator, we're going to have x plus 2 times x plus 3. Those are the quantities. Now let's do this one down here. This one's a little bit trickier maybe because we've got a minus here, so we're going to have a negative times a positive. Can you think of two numbers that multiply to get negative 14 and then add to get negative 5?
I'm not sure.
Okay, well let's do the factors of 14. 14's even, so we know it's 2 times something. What's it 2 times?
7.
2 times 7, right? So let's see. And if we had a minus 7 and a positive 2, that would, if they multiplied, it would be minus 14, right? A negative 14.
Yeah.
And what would minus 7 plus positive 2 be?
-5.
Okay, so that would work, right? So
Yeah.
-7, +2. So up here was x plus 2, x plus 3. Here was x plus 2, x minus 7. So let's write that down before we forget it. Okay, does that look like what we just talked about?
Yep.
Okay, good. So now we've factored the numerator and factored the denominator. And now what do you see that you could cancel there?
The x plus 2.
Right? So let's go ahead and cancel that. And then what would be left?
X plus 3 over x minus 7.
Good. Exactly right. Now, if you want to, you can even simplify further by just getting rid of those extra parentheses. You don't really need them, and you could write it that way. Okay? So see how this right here is so much simpler than what you started off with?
Yeah.
That's why we go through this to factor and then simplify. And that's what simplifying rational expressions is all about. Let's do one more that's a little tricky, or it's actually maybe easier, but it doesn't look like a trinomial, so you might think, oh gosh, can that be factored? But let's look at this top. Let's look at the numerator. Do you see how you could factor something out of both of those terms?
Yeah.
What would you factor out?
The x.
X. And what would be left over?
X plus 4.
Good. And now how about on the bottom here? Is there anything you can factor out of both of those terms?
No.
How about, well, there's no x, right? No variable that you could factor out. But what about, is there any number any factor that's a number that they have in common?
2.
2. So you could factor out the 2, right?
Yeah.
And then what would be left over there?
4 plus x.
Right, or x plus 4 if you put it. So, okay, so let's write out what we said there. So then you'd have, on the top, it would be x times x plus 4. And then on the bottom, it's 2 times x plus 4. Does that make sense?
Yeah.
Okay. Then do you see anything that could be canceled there?
The x plus 4.
The x plus 4, right? So we'll go ahead and cancel that out. And then what's left?
X over 2.
X over 2. And wow, you see how much simpler that is than what was over here?
Yeah.
Okay, great. So that's what rational expressions is all about, is finding that stuff that you can cancel and getting to something a lot simpler. Make sense?
Yeah.
Great job.